Without ado, I'll introduce tonight's speaker. His name is Chuck Peddle, and he's president of Sirius Systems Technology, Incorporated. He is a designer of the Commodore PET computer, the 6502 microprocessor, and of the Sirius Systems machine, which is represented here as a Victor 9000. And he's going to talk tonight about where the market is going and, to a certain degree, where his company is going. Chuck?
What I'm really going to do is talk about where some things came from and where we are. We're probably going to have a press conference very shortly to talk about where our company's going, so I won't steal that. The one thing I can say is that this morning I lost a lawsuit, so the name of the company won't be Sirius Systems anymore. We'll talk about the solution to that problem next week. Hello? Hello? Is that better? I wish I had a better mic. Okay. Is that better? Got everybody? Good. What I thought I'd talk about tonight is a little bit about third-generation computers, and because I was asked to keep it a little not salesy and a little bit not totally technical, I thought I'd explain what a third-generation computer is by talking about first-generation and second-generation computers and how they happened. And because I was flying in and I read Adam Osborne's misinformation about how this business happened, I thought I'd correct a few of those along the way. I'm allowed to take swipes at Adam behind his back because I take them to his face too. Basically, the first generation, by my definition, I think somewhat accepted by most everybody, was the original single-board computers. These products were introduced in early 1975, and they were a direct result of a market factor. They had to do with the introduction of the 6800 and 8080 microprocessors in 73, 74. The fact that the industry that had been the electronics design industry and a variety of related businesses all had suddenly faced a major technological change. For most of you aren't old enough, but those of you who are will recall that we used to have to design computers one gate at a time. And back in the old days, one transistor and one resistor at a time. Some of you even did it with tubes. But all of a sudden, we were faced with an industry dramatic change where about 80% of what computer designers used to do was already prepackaged for them. It was a circuit designed by a bunch of semiconductor types that didn't understand architecture so well. So what we had to do was to relearn what these bad guys had done to make up our new building block for how electronic design was going to happen. I had the pleasure of being part of the 6800 design team and was involved in part of this learning experience. And so we went off to do the 6500 family. One of the things that after we had the chip done, we started to address was how did people learn how to use this product? There was a person by the name of Jerry Ogden who was the first guy that I ever heard that suggested that in order for people to learn to use microprocessors, that somebody ought to come out into the marketplace with a series of plug-in circuit boards that would allow people to easily interconnect their own system. He came up here with me to Cambion here in Boston in, I think it was late '73, and tried to get the idea sold. It didn't take directly, but when we introduced the 6502 in late '75, we introduced a product which was developed by a calculator designer called the Kim-1, which is effectively a supercalculator on a board that allowed you to program a computer using a calculator keyboard. There were a series of products introduced almost simultaneously with this, The one that is probably the closest identified with the first generation computer marketplace was the Altair by MITS. Without demeaning them in any way, I would point out that MITS at that point was a going broke calculator company who managed to turn their fortunes around by introducing a computer for people that wanted to learn what microprocessing was all about. Other companies that came about at that time was a Digital Group, which was also started prior to the time we introduced the 6502. The major thing that happened with the introduction of the 6502 is that we dropped microprocessor prices from $300 a pop to $25 a pop. One of Adam's lies was is that Wozniak only had $10 for a microprocessor. I know for a fact he paid $25 for one because I remember the day he bought it. He didn't get a discount. The factor that was driving this desire, in addition to wanting to learn what a computer was all about, is that coming out of the universities at this time were a series of engineers who had been trained in the use of computers with time sharing. They wanted to have a computer of their own. The work that was done here with the original time-sharing products at Dartmouth were effectively made each person that sat down to a teletype believe he owned his own computer. About the same time, those of us that did have our own computers were thrown out of the computer room because of the fact that people discovered that if you didn't let the programmers get in and muck up the machines, the data processing guys got to exert more control and have bigger budgets. So we had two factors that happened in the marketplace kind of simultaneously. We had the ability to have very cheap computers for people, and we had a group of people who wanted to have computers. The first generation guys were, however, quite limited. Almost all of the products were sold in kit form or on a board with a stupid little calculator pad. And you had to program the machines in hex, and you had to dream up your own TV interface, and you had to hang together your own cassette. And so what happened is we started developing computer clubs. The computer club at that point was a place where people went to help one another debug their computers, to trade back and forth old used hardware that one another had, and to steal Bill Gates' Microsoft Basic. There wasn't a hell of a lot more software out at that time, and what was happening is the guys were writing very trivial programs, and at that point in time nobody really thought about selling them. Gates used to write ugly letters, but nobody else worried too much about selling software. It was really an opportunity for everybody to share in the learning experience. So we had the first market was really generated by people that wanted to have the computer, that were really trying to survive as either technicians or engineers by developing and learning about this new generation of product. One of the facts we discovered starting to look at this marketplace is that once a guy got his computer working, and once he was satisfied he understood the microprocessor and the technology that was associated with it, oftentimes the computer would then gather dust. As a matter of fact, I was talking about 6502s. There was a whole series of guys who wanted the care and comfort of the fact that they could buy a microprocessor for $25, to the fact that we sold something like 600 of them the first day we introduced them at WestCon. Only half of those ever got out of a desk drawer. There's a whole bunch of guys still happy to pull them out and show them to me from the time they originally had them. It was a feeling of warmth and comfort at that point. What we discovered, and I went into the semiconductor business to find a home in the systems business, and so I was looking for something equivalent to the breakover from mechanical calculators to electronic calculators to make my fame and fortune. And one of the things that came out of visiting the computer clubs, and talking about our CHEM and talking about the 6502, was that there was a class of person who could have his own computer, and there was a class that couldn't. The class that could was a guy who could build it himself, and who really cared about what the programming characteristics of a 6502 VIA was. The classical computer programmer, the person that had been a COBOL hands-on programmer or even a basic hands-on programmer, but had never gone into the hardware aspects of the business, had no opportunity to participate in this computer revolution. Many of them joined clubs but were frustrated. Byte stores happened, and about part of their business was making computers for people that did this, but this is a pretty expensive process because you were effectively making them one at a time in a store with somebody soldering them together without instructions and without the ability to test them. Memory was still expensive, and so you really had a product that was demanding for a next generation. We had a second factor that happened right about this time. The byte stores happened. They were a retailing outlet designed to service the need of people that wanted to buy these little computers. If you look at actually what was happening in byte stores, they were selling a hell of a lot of manuals. That's how Adam got to be famous. But without, and some hardware. But what they really were doing was selling computer knowledge. There was a company in the marketplace at that time who defined their future as being the neighborhood electronics store. They were in the process of destroying their major competition, Lafayette, and they wanted to stop this little upstart phenomena from happening. About the time that Commodore bought MOS Technology, the place I did the 6502, they were talking to Radio Shack about a product which could be sold as an assembled product by the average Radio Shack outlet. Could be sold at such a low price the byte stores couldn't compete, and they would put them out of business. From such desires, an industry happened. In late 1976, we set out to build the product that Radio Shack wanted and that was really responding to the need of the computer programmer in the hobbyist computer club. The guy that wanted a machine for himself, but didn't want to have to mess around with it. In addition to the Radio Shack specifications, it was those of us that had been around when time sharing came into being recognized that one of the things that made time sharing work was that people could sit down to the computer and get instant success within the first hour. And so therefore, that was our fundamental goal, was to have a product that could be sold through a retail outlet, and it wasn't necessarily just Radio Shack, that could be serviced by a low-level distributor, and that could be handed to a user who was semi-computer literate and who could have the machine up, running, and doing something with it within an hour. The decision to package the product with a CRT built in came out of a calculator salesman who worked for Commodore, who pointed out that people just didn't want to carry around a computer and hook it up to a television set, but that in fact if you put the thing together and you made it look attractive, you'd have a product that was far more meaningful to the average consumer. One of my first arguments with Wozniak, who up until then had been a customer, was over that particular fact. We were looking at buying Apple, which if it had happened would have set the industry back about 4 years. But we were looking at buying Apple instead of designing our own product. Luckily, Jack Tramiel was too cheap to put up the extra $50,000, and we got an industry out of it. And we went on to have Wozniak believing that the hobbyist, the super hobbyist, which he was trying to develop the Apple II for, wanted a computer that he could hook up and play with color and sound. The Radio Shack product had been defined as having a product that hooked up to a standard black and white TV and that worked with a low-cost cassette. Based on our own pricing goals of trying to get a product at under $500 and that had all of these other ease-of-use features, we decided to go with an integrated black and white product. And that became the first differentiation between the PET and subsequent TRS-80 and the Apple. Two products were developed in early 1977 then. The Apple II, which was designed to be hooked up to somebody else's television set, and the PET product, which was designed to have its own integral product. We were successful in demonstrating the product to Radio Shack they wanted. On the other hand, we weren't successful in developing a business relationship with them, so they set off to do the TRS-80. And in March of 1977, the Apple II and PET were introduced at a marketplace that showed that the market had changed and was real. The West Coast Computer Fair was a direct derivative of the computer club in the Bay Area. They put together the first fair, not to sell packaged computers, by the way, but to bring together a fair where all of the guys who had been going to the clubs and bringing their hardware together could get all of the guys on the East Coast to come out, and all of them would trade wares and sell product. The introduction of the two packaged computers, or second-generation product, at that fair, combined with the fact that 25,000 people walked in and spent, I think it was $20 a piece, to show up and watch other vendors sell product, indicated that we had a new market. The difference between the first-generation product and the second-generation product was in two areas. One, they were fully packaged and you didn't have to build anything to make them work. Apple had an illegal connection to your home television set, or they would sell you a black and white monitor. The other major difference, the thing that really distinguished the second-generation product from the first-generation product, was the packaging of the software. ROM technology had exploded in the 2 or 3 years since the microprocessor had occurred. We were intending to be a factor in that marketplace. And because Commodore's semiconductor capability, we decided to stuff as much Microsoft Basic as we could buy into a ROM, develop our own operating system, and try to make the computer appear to be a time-sharing computer. By virtue of having aimed at a market that we never really sold as much product into as we sold other products, both Apple and ourselves had stumbled upon the product that made the personal computer industry happen. A product with a packaged computer, had an operating system and BASIC in it, and had the ability to be used by almost every man that walked up and tried to run a program on it. I would point out there was one major limitation with the product that limited it to only that market. At that time, you loaded the product with a digital cassette. The last piece of code I ever wrote was writing the algorithm by which we were able to recover data off from the cheapest cassette we could buy. At that point, I burned out, and I've never been able to write code since. Late in '77, Radio Shack introduced their version of the product. They actually introduced the first business-oriented personal computer. They made a great splash in the Wall Street Journal about the fact that you could write payroll on your cassette-driven 4K TRS-80, and you could actually theoretically run payroll for 12 people on that product. Luckily, the business industry didn't grab it, and it took us a while until we started to really service the product of a business computer. The thing that actually made that happen, and the major break in the marketplace that occurred next, was when, from '77 until mid-'78, the marketplace was selling all the cassette machines that we could get, and some people actually got up to hooking up 16K, and we were really winging. The major thing that happened, and the thing that Steve Wozniak doesn't get enough credit for, was the introduction of the very low-cost floppy disk to the Apple II. That occurred at the next West Coast Computer Fair. I want you to notice the thread of the computer groups and this industry, because Woz introduced it as a cheap, fast way of loading programs, because he got tired of loading programs off cassettes. The combination of those two disks on an Apple II with enough dynamic memory is what made the business computer marketplace suddenly realize that the thing that everybody thought was a toy, that had been designed for people to have for themselves, was suddenly a business computer. To give you a feel in Apple's shift in emphasis, in 1978, they introduced it at West Coast Computer Fair. In 1978, summer, Apple only attended the Consumer Electronics Show. They passed on the National Computers Conference because it wasn't of interest to them. They weren't selling a product in that marketplace. In 1979, Apple decided to attend NCC and did very well. In 1980, they took over Disneyland at NCC to announce their version of the business computer, the Apple III, which is really and truly the first attempt at a third-generation computer. To put the industry in perspective, in 1977, when I put the pad out first, the same guy that decided to package the machine the way that we packaged it decided to prove to me that I was wrong about there being a market for computers. He had a survey done in Palo Alto, California, one of the technology centers of the world. Less than 10% of the people indicated that they would have any reason to buy a computer for themselves. You can't sit on an airplane, sit in a restaurant, or hold a casual conversation with a stranger in today's society without discussing which computer they're going to buy. That happened in 5 years. In 1981, we had our first third-generation computer, or pseudo-third-generation computer. IBM finally caught on to the fact that this was a real business and introduced their product, which is designed to stop Apple, the IBM personal computer. In fact, what really happened, in November 1981, a company called Victor Business Products introduced what I consider to be the first third-generation computer at the Comdex show. The most important thing about it was it's the third product designed by a calculator company. First, second, and third generation were all designed by calculator people. It was, in fact, a product designed to be sold by an entirely new distribution channel, the Office Products Marketplace. Because the product is aimed at the market for which we never intended second-generation machines to be at, it had to have different characteristics as well as a different channel. I'd like to give you a brief definition of what I consider to be third-generation microcomputers, and then I'm going to spend a minute talking about the marketplace. My definition involves that it has to have a 16-bit micro. The reason for that is one of the major limitations of the second-generation machines was that 64K, particularly when you had to take memory space out for the operating system and languages, just wasn't enough. And almost all of the business applications ran out of steam. The 16-bit micro also gives you some memory protection and orientation features that allows you to truly use high-level compilers. I feel that any third-generation computer has to offer all of the higher-level languages. Because it's a business-oriented product, it has to be able to allow you to move programs were written for higher-level machines more easily, and also to allow the marketplace to properly expand, you have to have languages which have been used for business solutions. In my opinion, it has to have 128K worth of memory minimum. The reason for that is that if you don't get any real advantage out of the languages and/or out of the higher memory unless you have that. And in my opinion, we're going to very quickly decide that a machine that can't run at least 256K isn't a business computer at all. I believe it has to have high-resolution graphics. We believe, when we did the original PET, that the ease of use of character graphics and the low memory utilization of that would allow the average user to start. Apple clearly was a pioneer in the concept of high-resolution graphics and has shown that any machine that's going to really penetrate the business market or the user-friendly, sophisticated user market has to have high-resolution graphics. It's my belief that you have to have at least one channel of synchronous communications capability, because almost all of the business computers should have the ability to hook up to a large database over a sophisticated channel. And therefore, my belief that asynchronous communication is not enough. I feel that the third-generation microcomputers, because they're aimed primarily at a business marketplace or a professional user, will be used for large numbers of amounts of time per day. Therefore, I believe part of the definition has to include European ergonomics as a standard feature. To give you an example, you see in front of you a machine which fully meets that ergonomics, the Victor 9000. It has a no-glare screen. It has a tilt and rotate and separated keyboard characteristics which are defined to meet the standards which were developed in Germany for use in an 8-hour-a-day office environment. It's my belief that all machines which don't meet that characteristic cannot be legitimately called third generation. I believe you have to offer at least 1 megabyte of disk. Almost anybody that's attempted to do more than 12 payroll on a disk quickly discovered that even though Wozniak made a great breakthrough with his 100 kilobyte disk, that in fact at least 1 megabyte is really required to do any kind of serious processing and storage. And I believe you have to show the user the ability to expand up to at least 10 megabytes locally. I think you have to have the ability to have network expansion, because it's my belief that in a business environment, computers have to talk to other computers, and they clearly have to talk to other databases. I would not make it a requirement of third-generation products, but I think very soon we're going to all agree that voice out is also a requirement. I point out the only other company that I've given true credit for having a legitimate third-generation product, DEC, like the Victor product and Sirius product, also includes voice. But we won't make it part of the definition, because I hate to have a null set or one or two people in the set. And we've now invited some of the other companies to start to create product that truly meets this definition, as opposed to making pretend. Where do I think the market's going is very simple. I think the business computer marketplace, the third-generation kind of product, is going to be continually developed in a more and more of a network and database-oriented environment. And people will be able to buy a computer to use on their desk today, which will solve a problem that they want to solve today economically. That very soon, several people in an office will have common database, and you will have to have the software and hardware to support the sharing of databases so that people can really work together to solve a business problem. I think that very shortly after you have the ability to put databases into office environments using networks, that everybody in the office will demand access to the database. That it won't become a question of, can I have a computer on my desk, but why can't I have a computer on my desk? Are you trying to keep me from progressing as a professional? The other thing that's going to happen, and the other exciting part of the market, is the very low-end computer market. The last thing my team did at Commodore before we left was to help create the follow-on to Clyde Sinclair's throwaway computer business, the VIC family, which I think shows what really we intended to accomplish in the second-generation computer. The VIC-20 and VIC-40 were truly second-generation computers revisited. Only this time we learned that Wozniak was right and you had to hook them up to a color computer. And you had to sell them for $200. And I hope very soon that Tramiel gets forced into selling it for $99. Because it really then becomes disposable computing for education purposes. I think you'll have a computer at your desk. I think you'll have a computer at your laboratory. I think you'll have a computer at home. And I think you'll have a computer for on the road. And I think all of your kids will have a computer. If I had the perfect answer, I'd tell you how you're going to connect them all up so that they can all talk to the same database, because that's really going to be the question. And when I come up with that, maybe I'll have a fourth-generation product.